All right, we're good to go. Hi, everyone. How is it going? Thanks for joining us today for this talk, which is about ClickHouse. I don't know if everyone heard about ClickHouse here in the room or no, but I hope that after this talk you'll have a precise idea of what is ClickHouse. And we will be talking about how we design and build ClickHouse for fast. And you'll see that fast is a very wide concept. So my name is Ryadh. I'm the integrations product manager at ClickHouse. And today I'm with my colleague Dale.
Hi, I'm Dale. I'm a product marketing engineer at ClickHouse. I'm not sure that fully encompasses what I do. I work on the clients, the Grafana plugin, and produce a fair bit of technical content. So thank you for coming.
So I don't know if you noticed, but the description of the talk says that our colleague Tyler Hannan will deliver it. But Tyler could not come due to family reasons, so we had to pick two people to replace one Tyler. That tells you how it's challenging. But I landed in London 2 days ago, and I arrived in Gatwick Airport. I was thinking about this talk actually and how to open it. And sometimes, you know, when you are like hyper vigilant because you are focused on an idea. So I was looking for things around me, and I arrived in Victoria Station, looked up and saw this billboard. So it's a live photo from yesterday at Victoria Station. And it says that the 1971 Italian Monza Grand Prix was won by only 1% of a second. So like 10 milliseconds made all the difference on the outcome of that 1971 Grand Prix. And it definitely resonates with someone who deals with like fast data at scale and queries and the millisecond scale. So with Dale, we were curious and we started Googling around this 1971 Italian Grand Prix. And it turns out that this individual named Peter Gettin from Surrey won that 1971 Grand Prix by 10 milliseconds. And he also scored the record of the highest average speed on the racetrack ever until 2003. And Michael Schumacher also scored the same record on the very same racetrack. But 2003 and 71 are very different eras for mechanics, and that was quite interesting, and it shows that milliseconds matter, especially in spaces like Formula One, where you expect that. But there's also other areas where milliseconds make all the difference, and that's how you measure certain things. For example, the time for a photon to travel 300 kilometers in vacuum is around 1 millisecond, and then you can take it from there. I play music, and the tune A, which everyone tunes his instruments to, it has actually a cycle of 2.27 milliseconds. Your screen on your computer refreshes every 16 milliseconds, which leaves enough time for your spinning disk to do, on average, 4 seek operations. And you can build it from there. You cannot hear anything lowest than 50 milliseconds cycle time. And your average resting heartbeat is at 860 milliseconds. These examples are important for this talk because it gives you a good understanding of what these scales means and how many things can happen under the second. So for the next slide, I have a question actually for the audience. I have this data set. On the top, there's a select count from GitHub events. This GitHub events is, as the name says, all the events from GitHub since 2011. And it's a 5 billion rows data set, so it's quite massive. And I have this query at the bottom, which will tell me the breakdown of stars for the repository ClickHouse per year. So my question is very simple, and please listen because there's a t-shirt to win. So the closest answer will get a t-shirt. How many of these query I think we can fit between 2 heartbeats? Remember, heartbeat is 860 milliseconds. 5, we have 5 here. Another guess? 3? Sorry? 500, wow. All right. Let's see. Sorry? 400, okay. 100? 400? 42. That's a nice number, actually.
Okay.
And one last guess. 20. All right. So let's see together, basically, if you go to our public instance on the internet, you have actually a ClickHouse instance that's accessible to everyone to query. And run that very same query, it will return in around 14 milliseconds. So this gentleman at the back, you just want a t-shirt. You can come pick it up at the end of the talk. 14 milliseconds to tell me the breakdown of starts. And it means that we can fit around 60 of these queries. So if you don't believe me, you can try it yourself. We share the link here to our public instance, so we cannot really fake it here. All right. Now, what is ClickHouse? So ClickHouse is, first of all, an open source project that was started in 2009, that went open source in 2016, and has more than 25,000 GitHub stars. So it's a fairly popular database out there. We have more than 1,000 contributors, 300 releases, and a huge user base that's using it every day to answer very tough questions on very large volumes of data. It's also a column-oriented database, which means that's our trick to answer questions very quick. We store data not by row, but by column, and we can benefit from very interesting effects like very good compression, very good analytics capabilities. We are a distributed database, so we can scale to the million and billion and trillion scale quite easily, and I hope you get to see that today because we prepared some demos for you. And as an all-app database, we're perfect for these users that have massive data and questions, and they want a dashboard on top of their data, but they don't want this dashboard to hang for 1 minute every time they tweak a filter. They want a real-time analytics experience, and that's our sweet spot. This is the GitHub star history. So we're the red line here is our trajectory in terms of popularity, and we're quite proud about this because we have open source roots, and that's very important to us. But it's a fully fledged database, so we speak SQL. You can come with your background of SQL. We also extended the SQL standard to have a version for analytics, so we have more table functions, we have specific things to ClickHouse that makes it very powerful in an analytics use case. We can deal with huge ingest rates in the scale of millions of events per second quite easily. You'll get to see that, I hope. We can distribute data, we do a very clever use of storage, we have a very good compression capabilities built in the tool, which means that the data on ClickHouse takes very often orders of magnitude less than the data deflated. Obviously, very fast queries. That's now, I think you saw some proof. Also, we are building a service on top of that called ClickHouse Cloud that we will release early October. So be on the expected for that date because we'll be able to have all of this experience in a serverless, auto-scalable fashion. So now, that's the philosophical part of the talk. So I'm sorry if we lose some people here, but I'll try to do it. Tyler is way better than me at the philosophical talks, but what is fast? We just saw in terms of query time what it means. But actually, there's different aspects of facts that make a good product, a good company, and a good open source database. And we'll try to go through this, and you'll notice that some of them are not that obvious, actually. So we're in the UK, and I've checked the UK road sign book. Is there any driver in the room who can tell me what's this road sign about? Recommended speed. It's actually the minimum speed authorized on that road. It's kind of not obvious because it's a very rare road sign, but it means that on that road you cannot drive under 50 miles per hour. Does it ring a bell to anyone? Like you cannot drive under 50 miles per hour? Or do you need more hints? So it's a movie from the 90s where you cannot drive under 50 miles per hour. Speed, nice, good catch. That's also a childhood memory for me. It's a kind of thriller, and the whole trail comes from this threshold, 50 miles per hour. So if you go under 50 miles, then the bus will explode. That's a very simple scenario. And we can use that actually to gamify a little bit our demo scenario. So I prepared a set of challenges for Dale based on that movie plot. So we'll have thresholds, and Dale will have to run his queries given that threshold. Otherwise, I won't say the bus will explode because it's not a very positive image, but the message bus will explode, let's say. So first aspect of fast, which is fast operations. So let's say you want to run open source ClickHouse. What you will do? You need to download the package, prepare Linux box, update it, secure it, open the ports, network, connectivity, users, install the package, make sure it's sound, expose it to the users somehow, open the firewalls and make it available and load your data in. That's operations around the database. That's a pretty classic thing to do. But what if I told you we can do that faster using ClickHouse Cloud, for example? So my challenge for Dale, and I really hope we will stay friends after this talk, is to do that in less than 2 minutes. Dale, can you?
Okay, thanks, Ryadh. Let's see what we can do. So I'm going to see if I. Please don't start the timer until I've actually navigated to at least the URL.
I have a timer on my watch here.
So ClickHouse Cloud. I'm going to log in. I think we had a discussion as when it's fair to start this timing. But when you first log into ClickHouse, I'm going to delete this cluster. It gives you some idea what I might name it. This is everything we do with regards to ClickHouse Cloud. We think about simplicity and just providing as simple interface as possible. So when you, rather than create a database, you create a service that is in effect a ClickHouse cluster with a number of databases. You can create databases within that and tables within those databases. But all our approach to operations is as simple as possible. So take away and abstract the complexity for the user. If I create a service, all I have to do is choose a region. And I think it's fair to start now. So if I was to say, I don't know, 120 seconds isn't too long.
All right, stopwatch started.
To make it a little bit easier, I'll just say we can access this from anywhere, and we're done. Okay, I will close this and come back to this. So this is gonna, and whilst we're waiting for that to create, hopefully that finishes in 120 seconds and I pass the first challenge. But let's just do a quick tour of the UI before we start issuing queries. So as I said, these are services. We support vertical scaling in our beta. That's coming soon. So resources will respond to your workload and vertically scale up and down. And we plan to horizontally or also dynamically scale under load.
40 seconds.
So list of integrations, a lot of friends here, a lot of companies from around that are at this particular conference. One of our key integrations would be Amazon S3. So as well as supporting bringing data in from S3, we do that in ClickHouse through what is effectively a table function in replacement
1 minute.
The table name. We also support querying data in S3 in the Athena style use case. We support a number of file formats, Parquet, CSV, TSV. We automatically support compressed files. In this instance, we're querying gzip. So let's just copy this query. And we're not quite there. How am I doing on time?
We're at 125.
Ooh.
That's not looking good for the bus.
Sorry, 125 seconds or 1 minute 25?
1 minute 33 seconds.
Okay. Let's. So other integrations, obviously our core visualizations that we support, plugins for Grafana. This is close to my personal heart. Superset. We also support Metabase, and then just your classic clients, and we have first-party
10,
first
9,
class-supported clients,
8.
And we've just about done it.
All right,
it's a little bit closer than I hoped. A little bit of pressure there, but okay. So let's just issue that query, so we can go to a simple UI. I'm going to copy that query in. That query's S3. I'll take the password and can execute this. So in this instance, as I said, we're not actually querying the data inside ClickHouse. We're querying the data in place. And this is great for like ad hoc analysis. If you need to actually get the true performance of ClickHouse, you would bring the data into ClickHouse. But this is an interesting use case. And this is about, I think, about 100 gigs worth of data on this New York taxis trips, and we can see that we can get, here's the first 10 rows. So this is great for ad hoc analysis, it's great for looking at the data. It's not what we would recommend, obviously, for queries that need to be performant. And I think, back to Ryadh, what's my next one?
Well done, Dale. We're still friends.
5 seconds to spare.
All right. That was close out. When we rehearsed in the rehearsals, we had more margin than that. So I'm a bit worried for the rest. But okay, that's one obvious aspect. That's one non-obvious aspect of fast, which is the ability to spin up a service very quick and get going. And as you saw, the S3 table function is really powerful because we checked a remote data set without ever loading it into ClickHouse, which is a luxury. Then you can then pick the fields you are interested in or the shape you are interested in and actually store it in ClickHouse, which is our very next task. So, time to load data. I promised you a very fast, scalable database, so now we need to deliver on that promise. So the challenge for Dale is to ingest 1 billion rows in less than a minute and a half. Good to go, Dale?
Yeah, I'm feeling a bit more confident that this is a little bit more deterministic, so I'm a little bit confident this is going to be a little bit easier. Here I've got a ClickHouse cloud instance, ClickHouse instance on version 22.9.1. To insert data into ClickHouse, we first need to create a table. Similar, there's a few things that are unique here to maybe our SQL and our approach, but the main key is the difference in the order by. This really defines how our data is ordered and stored on disk. And then you can see that in this particular GitHub data set, we have all the issues, all the commits, all the pull requests, all the comments as an event type. Then we have effectively actor login, which is your GitHub name, your repo name, and the repo name, and then the created time, and then an action. So was it a create event? Was it a delete event, for example? So let's create that table. That's pretty fast. This is a single server. And to insert data, to make this a little bit more interesting versus insert it from disk, I'm going to insert it and actually pull the data set in from S3. So I'm going to read this down onto this server, decompress these files. They're in LZ4, they're in TSV with names format, so they have a header, so we can infer the schema and the types of that data, and we can insert that in. So when I execute the query, there's always a kind of slight pause as we build the scaffolding for this. This is a pretty intensive query. We're starting to download the files, but we'll start to get query feedback, and the final timing should include all of the time that was spent on this initial scaffolding. So this is pretty huge. It's coming, and we'll start to get feedback as to our insertion rates. So hopefully we've got to get to 1 billion in probably now about 40 seconds. Getting 8 million rows.
Can you make the font bigger, Dale?
Should kill my Slack. Let's see, pretty close. So as we're downloading these files, we've downloaded more files in parallel. They're right into this. It's entirely parallelized. We're using the full resources of the box. You can see we're using 48 CPUs there to do this work. And I benchmark these disks with FIO at about 2 gig a second SSDs. So we try to aim for as close to the native machine performance as possible. There's a little bit of CPU overhead here with the decompression, so we might not quite get to 2 gigs, but hopefully okay, so 65 seconds, 1.13 billion rows inserted, and we'll use that data set now for queries.
And the average speed was 18 million a second, or 17 million?
17.3 million, 113 million rows a second, yeah.
All right, so yeah, that's good news for the bus. We're still safe, even though we had some risks in the beginning. Let's continue this challenge. All right, now the most interesting aspect of a database is usually getting insights out of it, running queries. Analytics queries can be heavy queries because they can scan a huge amount of data to retrieve often one or few lines of insights, actionable insights, hopefully. And in this challenge, we won't run one query, but we run 7 of them, I guess.
7, 8.
And the challenge for Dale is to stay under the half a second performance. Good to go there?
Yeah, I mean, so let's start off with something simple. So top repositories by stars on GitHub. Pretty straightforward SQL statement. Top 20 repositories in the last year. So I should say this 1.1 billion covers the last 12 months. You can see it's mostly kind of educational repositories. Those, I mean, we see that across the, if we query the whole data set, that's typically the most common pattern is that
Just
repositories that aim to teach people things are pretty popular.
that was 8 milliseconds close to the threshold.
Ah, sorry. Yeah, that was pretty close. Okay, so I expect this to warm up a little bit as we warm the file system cache. We've obviously just inserted this data, so hopefully I won't quite be as close to the target. So let's take a look at query 2. Distributions of stars. I think when I wrote this one, we kind of expected this to follow the power law. Like most repositories have 1 or 2 stars. Most of us just write code, chuck it out there. Use the fact that if we don't have a private repository, we don't have to pay. Would expect that's pretty comfortable within the half-second limit. Fortunately, ClickHouse is in one of the 179, so that's quite it's quite flattering. Let's try query 3. How has the total number of stars changed over time? So this is using kind of some basic visualization techniques, some extra functions in the ClickHouse SQL dialect. The bar function just allows us to do some pretty simple visualization, but let's just see how it's changed in the last 12 months. This is a little bit more interesting, honestly, over the full 11-year data set. In this instance, probably see a little bit of dips around New Year. That's probably about all we can really draw from that.
And it took 64 milliseconds, this one.
Yeah, we're getting closer. So people who starred ClickHouse, what else did they star? So this is a kind of a rough indication of friends, like maybe people that are working on ClickHouse or working on other projects at this conference. And pretty close, 0.2 seconds. This is an interesting framework, actually, Tory Apps. I wasn't aware of this. If there's any authors here or anything, I'd be curious to hear about it. It's their motto is blazingly fast JavaScript and blazingly fast applications, so there's some kind of synergy with ClickHouse there. Otherwise, kind of things that you would expect, I think, like Kubernetes, for example. Pretty much everyone's got an interest in that. And was that query 4? Query 5. Okay, what about people that contributed to ClickHouse? What else are they contributing to? So how many contributors do we share maybe with other open source products? In this instance, this is a little bit more complicated in that, first of all, we have to do this kind of inner clause to figure out who are the contributors to ClickHouse and then filter that across the data set. But also very, very fast. DuckDB, interesting project. Doris, StarRocks, I think, are here. So interesting to see that we share committers. Finally, most commented repositories. I'm not sure this is a good thing. If you get lots of comments, is that a sign of activity, community activity, or is that more a sign of issues with your code? I don't know. I'm not sure if it's a positive or a negative thing, but interesting as personally as a former employee of Elastic, that Kibana generates a pretty significant amount of comments and activities you'd probably expect. And then finally, which organizations have the highest amount of community activity? So by pull request, issues, push events, if we create buckets for those. This is actually quite a computationally expensive query in that we have to do this unique F on every single clause. So there's a lot of substring and string operations here. Yeah, unfortunately, that's not going to take half a second. But I suppose the lesson is that not all queries can be done in half a second, even in ClickHouse. But interesting to see that Microsoft have obviously a lot of projects, a lot of activity, as do Apache and Google. Finally, I was kind of curious at the start of this talk, I don't know if I thought I'd do this fairly ad hoc, is just to demonstrate how ClickHouse can utilize all the cores. You can see I've got 96 cores here. I was kind of like thinking this morning, could I write a query that just doesn't use any data, but just tries to do enormous amounts of computation on something silly? And I kind of inspired to do like a Monte Carlo simulation on trying to compute pi, and how much, what could we do if we tried to compute pi? So this is in effect like a kind of a random computation of pi, and we can compute at 27 billion rows per second, and you can see there that we're using the entire machine to compute that. And I'm sampling in that Monte Carlo simulation 100 billion rows in 11 seconds to try and do that. So 800 gigs worth of data. Wouldn't recommend that's very accurate. Float 64, probably after about like the 6th, 7th decimal place. That's pretty irrelevant. But it was reassuring that pi is 3.14. So, back to Ryadh.
Thanks, Dave. So, unfortunately, we lost the bus, but we had to sneak in that query because otherwise it's not funny if we always are under the threshold. But you just tell me that you used 96 scores to tell us about a number we know about for like 2,000 years.
Yeah.
All right.
Probably a waste of my time. Probably not what ClickHouse are paying me to do.
Okay, thanks. All right, let's jump into another aspect of what fast can mean, which is non-technical. It's actually about our ability to deliver features, updates, upgrades, make the performance faster, to deliver a good product with sane engineering, and how to be the culture of fast. So I've tried to highlight a few aspects of that here. The first one is that we have a very aggressive release schedule. Actually, a lot of people are surprised when they see our versioning schema, but it's just the year, the month, and then some version number, which means that we have a monthly release cycle. Every month we release ClickHouse, and by the way, today is our release date, and if you're curious, there's a release webinar. You can find the link on our website this evening around 5 or something. So every month release is full of features, full of fixes, full of improvements. We do release at a slower pace LTS version, which are long-term supported versions, every 6 months, so every March and every August. So if you want to stabilize your production environment, please pick one of these, like 22.3, 22.8 for this year, for example. And we have a longer support cycle for these. And I picked a story of one particular feature here to highlight how brave the engineering team can be at ClickHouse, which is the story of a part of the project called ClickHouse Keeper. I don't know if you're familiar with Zookeeper here. It's a fairly old, successful open source project that is used to power the states of platforms like Apache Kafka, for example, and others are using it. And we used to use Zookeeper as well for our distributed version of ClickHouse to maintain a coherence of the cluster and the state management of it. But we end up having the classic Zookeeper issues. Every admin knows about that. It's a Java app, so memory pressure can be an issue. There's this question of ID resetting in Zookeeper that can create some issues as well. So we decided, the engineering team paused and said, what if we write our own implementation of Zookeeper? We called it ClickHouse Keeper. So the engineering team took a project that has like 15 years old and that has a lot of experience and tried to do their own version in C++ using Raft consensus algorithms. And they produced that. That's the number of issues at the bottom. That's the number of issues at the bottom they had to go through in GitHub to implement that. But we're very happy and proud to say that we released that at least 8 months ago, something like that. It's up and running. It's production ready. We have a lot of customers using it. Funny thing is that you don't have to use it just for ClickHouse. Actually, it's a keeper instance, so you can use it even to power other data apps. We're not testing all the scenarios, but that's a call for the community. If you are curious to run your Kafka cluster with ClickHouse Keeper, please let us know how to do. Don't do it in prod first. Do it in dev and be on the watch, but let us know how it works. It's actually a very solid piece of software, and we saw that in the issues opened in the repository that no one is complaining about Keeper anymore, so we're happy. Finally, and that's the beauty of open source, you don't have to believe what you just saw. You can try it out by yourself. You can just run the queries, and actually we can help you here because we also publish an open benchmark. There's a repository, there's numbers. It's called ClickBench. This is the big table we produce, but it's way bigger. We do compare something like 30 to 40 databases on the same data set and the same set of queries. It's completely open to contributions. It means that some of these contributions are external. Some of the vendors produced their own benchmark and contributed that to our benchmark. And at the moment, we're still number one, but who knows, maybe your submission will move this element, and you can visit that at our website called benchmark.clickhouse.com. This is the live thing. So let's go back to the deck.
Okay.
So with that, we displayed 5 facets or 5 aspects of fast data. Some of them are not that obvious. Thank you very much for your time today. We have a booth at the very end of this room where we will be happy to answer any of your questions. I promised someone a t-shirt, so please stay here. And please check out clickhouse.com/cloud. Early October, we will release something big there. Thank you very much for your time.